Something I forgot to mention in the previous lesson is a bit of a kind of gotcha that got me. I was stuck for a while because this was turned on. I think this is turned on by default when you create where are we? When you create a simulation with the shelf tool, right? And what happens with this is that you cannot have constraints between separate geometry objects. So if I turn that on, and if I turn on the guides, okay, so they're the red guides for the glue. Now watch when I play this, you can see the constraints are not working properly. So the agent's free to fly around. Okay, and then if I turn this off, play that, the agent's constrained to the chair. Great. Okay, so just wanted to cover that quickly because to save time, to save you the time that I lost kind of working that out. So we need to bring in the work on the rest of the plane, right? And the idea is to have I'm going to drop a group here. So the idea is that the back of the plane at some point will be ripped off, and kind of the agents will fly at the back. Yeah. So I'm going to create that group for that area. We're not going to go into a lot of detail with fracturing it and bending metal and all that. It's just at the back of the plane, and you know, it won't be very clear. So and it's not the focus of this lesson either, really. So you know, just a really simple group. So I'm going to call this animated, because this part will be animated, the rest will be static. And I'm going to use a bounding region, bounding box. Okay, and then 17, 17, 17 for the size, and then 7 by 23 I've got. Okay, so just to grab this section at the back, line this up, and then delete the animated part here. Okay, so this will be, I'm going to drop a null here and call this out static render. Maybe give this a color. Oopsie daisy, there we go. So this part, yeah, is what we will actually be rendering, because after here now I'm going to be setting up collision geometry for the bullet solver. And then over on this side, delete non-selected, and then we got that. And then let's animate this. Okay, so yeah, up to frame 100. We're not going to move it. Let me just put the pivot in the middle. So if we look now, the pivot's down there. So a handy little tip to put the pivot in the middle is to use this expression $CEX. Oops, you need capitals there. We've got $CEX, $CEY, $CEZ. So that will procedurally drop. Oh, I've got %. There we go. So that will procedurally drop the pivot into the middle of the geometry, right? So yeah, up until frame 100, it's static, doesn't move, and then after that we're gonna move it away. So at frame 120, set up that, and then I'm just going to drop in the values that I've got here. -20, -30, 10, -2, 105. Okay, so you can see it just kind of goes shooting out backwards. and then over to 134 there. Goes up a little bit. 252, 10, that's fine. Change it a bit to 11, 30, and 20. Right, so there we got this kind of shooting away, right? So you can see it's with this. Cool, and then the agents will fly out the back here. So if I drop another null for this one, put them parallel to each other so you can see them. Call this out animated and render. Color that purple as well. Okay, so now I need to start thinking about getting this ready for simulating, right? So what I'm going to do, first of all, something I commonly do is just delete the really small parts, right? So if I drop this measure and I set this to area, so that's measuring every primitive at the moment, okay? So you can see these really small primitives here are blue. If I set this to per element and then change it per piece and then change that to name, I think, get rid of that class. There we go. So that's now measuring everything that has a name. If I put this, you can see this, this, and this. That's all considered a separate thing now. I press 9, by the way, to get that selection up. And then try and get rid of it. There we go. I think we've lost that visualization now, but it doesn't matter. So this will be give me a an area for each of these small pieces here, which I can use to delete them, right? So I'm just going to drop a delete because we're not rendering this, and it won't really affect the simulation that much, but it will save simulation time. I can just delete them. So if the area is less than 1, delete, and then you can see all these kind of small parts go away. Okay, we'll do the same thing on the other side. Okay, that's great. Oops, is it all right? It's animated, I suppose, all the way back over there. So another thing we can do to save simulation time is reduce the polygons. So I'm going to drop a poly reduce there. My Houdini crashed there, so I've just loaded it back up again. So as I was saying, yeah, drop a poly reduce, and then I can bring this down to about 50%. Okay, so that will remove a lot of geometry, but keep the basic shape of it. So if you see now, if we check the point count, we've got 134,000 there, and then by here we've got 28,000. So we're, you know, getting rid of about 100 polygons, points, I mean. So I'm going to copy this over to the animated part as well. That will save us a lot of geometry here. And then what I'm going to do, because this poly reduce can take a bit of time, and we've got an animation above it, which means that every frame this is going to be recalculated, which I don't want. So what I'm going to do is drop a time shift here and then freeze this to the first frame. Okay, so now this isn't doing anything, and then just grab this transform, right click, create reference copy, and then drop that underneath. Okay, and we'll get an error because of this, the pivot. It doesn't like the copying over the $CEX thing, so we'll just do that again. So we'll delete those channels, and then just drop $CX, again, $CEY, $CZ, okay. and that way we'll get the same animation but on this low poly geometry. Okay, and it moves nice and quick. You can see if I template that, they're pretty much identical in the animation, right? Okay, so we can now merge them together, and we're almost ready to plug them into our simulation.